If arterial blood gases look like a group of confusing numbers to you, I'm going to show you how to identify the 4 main acid-base disorders using 3 values and a very simple step-by-step method. So this is going to be broken down in 2-part series. This is part 1, where we'll be focusing on basic ABG interpretation. We will discuss the uncompensated, partially compensated, and fully compensated in the ABG video part 2. But first of all, what exactly is an arterial blood gas? We all hear ABGs, and I'll tell you, an arterial blood gas, also called an ABG, is a blood test. This measures the oxygen level, carbon dioxide level, and acid-base balance of the blood. We all know that the kidneys help with acid-base balance. But unlike the regular blood test that is taken from the vein, ABGs are commonly collected from an artery called the radial artery on the wrist. So ABGs help us answer 3 important questions. Is the patient oxygenating adequately? Is the patient ventilating and removing carbon dioxide effectively? And is the patient's blood too acidic or too alkaline? So the main values reported on an ABG include the pH, the CO2, the bicarb, and the oxygen level or an oxygen saturation. However, we're identifying an acid-base disorder, and we will discuss the 3 main values. So let's head to the whiteboard. First is the pH. The normal pH is 7.35 to 7.45, and the pH tells us whether the blood is acidic or alkaline. So if the pH is less than 7.35, we refer to it as acidosis. And if the pH is greater than 7.45, we refer to the patient as alkalotic. So a simple way to remember this is the lower side is acidic and the higher side is alkalotic. So bear this in mind. Next is the CO2. The normal range is 35 to 45 millimeters of mercury. The CO2, which is the carbon dioxide, it tells us about ventilation or how effectively the lungs are removing carbon dioxide. So any range less than 35 is considered to be alkalotic, or any range greater than 45 is considered to be acidotic. The next is the bicarbonate. The bicarb is 22 to 26. Any range less than 22 is considered acidic, and any range greater than 26 is considered alkalotic. The simple memory trick to remember the range for this is 2 plus 2 plus 2 is equal to 6. Another important point to bear in mind is that carbon dioxide acts as an acid, while the bicarbonate acts as a base, and bicarbonate is regulated by the kidneys. So every time you're given an arterial blood gas value, the first thing to do is to check the pH. Step 1 is to check the pH. Step 2 is to check the CO2. And step 3 is to check the bicarbonate level. These are the normal ranges. Now we would move on to the disorders. Now that we know the steps for interpreting ABGs, let's talk about the 4 major acid-base disorders. A simple memory trick that you can use is ROME. R stands for respiratory, O stands for opposite, M stands for metabolic, and E stands for equal. Let me explain. So this means that in respiratory disorder, the pH and the CO2, they move in opposite directions. But in a metabolic disorder, the pH and the bicarbonate, they move in the same direction. That's what it means. So if the pH is low and the CO2 is high, it is referred to as respiratory acidosis. If the pH is high and the CO2 is low, it is referred to as respiratory alkalosis. Again, remember, respiratory disorders goes in opposite direction. Going on to the metabolic. If the pH and the bicarbonate is low, it is metabolic acidosis. That means they are going in the same direction. If the pH and the bicarbonate, they are both high, that is metabolic alkalosis. Now let's take some examples. Let's go through our first example. Look at the pH. The pH is 7.30, which is low. The CO2 is 52, which is high. The bicarbonate is 24, which is within the normal range. So this pH of 7.30 is below the normal range of 7.35, so the patient has acidosis. The CO2 is 52, which is greater than the normal range of 35 to 45. That means the patient has more acid. So with the pH going down and the CO2 going up, means they are moving in opposite direction. And CO2 is an indicator for respiratory disorder for ABGs. So this is respiratory acidosis. The bicarbonate is normal. So let us talk about another example. So this is example number 2. In this scenario, the pH is 7.49. That is above 7.45. So the patient has alkalosis. Step 2, we look at the CO2. This patient's CO2 is 30, which is low. Low carbon dioxide means there's less acid in the blood, causing the pH to go up. They are moving in the opposite direction. So we have the pH is high, CO2 is low, the bicarb is within the normal range. This is therefore respiratory alkalosis. Then we'll take another example. This is example number 3. In this example, the pH is 7.28. That is below 7.35. So the patient has acidosis. The CO2 is normal because the normal CO2 is 35 to 45. The bicarbonate is 18, which is low. So in this example, the pH is low, the bicarbonate is low. And they are moving in the same direction. Therefore, this is metabolic acidosis. So this is example number 4. In this example, we have pH, CO2, bicarbonate. Step 1, we're looking at the pH. The pH here is 7.48. And this is above the normal 7.45. So pH is high. And this patient has alkalosis. The CO2 is normal. The bicarbonate is 30, which is high as well. The pH is high. The bicarbonate is high. Therefore, they are moving in the same direction. And this is metabolic alkalosis. Well, these are practice examples. Let me know in the comment section if you do understand or you need more clarification. We would be closing up with part 1. In part 2, I'm going to show you how to determine whether an arterial blood gas is uncompensated, partially compensated, or fully compensated. If this helped you, please like this video, share, and follow for more. Happy studying.